This video is going to discuss electric field strength. The objective is that students will be able to recite the equations and qualities of electric field strength. If two negatively charged balloons are brought near each other, they would repel because that's what like charges do. The question is, why do they do that? It's because all charges have electric fields around them, and these fields are invisible to our eyes, but they are the cause of the electrostatic force. So basically, when these fields interact from two or more charges, that's where the force comes from and makes them either attract or repel, depending if they're opposites or like charges. How strong an electric field is depends on two things: the amount of charge that's there, measured in coulombs, which is C, and the distance from the charge, measured in meters, which is M. And the equation is E equals kq over r squared, or that E stands for the electric field strength measured in newtons per coulomb. There's another way of representing this, and that's the electrostatic force divided by the charge. In all these equations, Q stands for charge, R stands for distance, F stands for the electrostatic force, and K is that Coulomb's constant that has the value of 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. As the distance from a charge increases, its electric field has less strength. And as the amount of charge increases, its electric field strength also increases. Now for a challenge question. If the distance from a charge is tripled, by what factor does its electric field strength change? If you were thinking it would be 3 times the electric field strength, that would be incorrect. Since it's further away, there's less electric field strength. Field strength and distance are inversely proportional. So if you're thinking, since now we have to eliminate A and B, they show increases in electric field strength, that the answer has to be C, because 3 times the distance, 1/3 the electric field strength. That seems to make sense. Except that R is squared, the distance is squared, so we need to square this factor of 3, and we'll really get 1/9. To recap, electric field strength depends on the distance away from the charge and the amount of charge present. Please remember to complete the EdModo questions, and as always, thanks for watching.